maximum height allowed for an emergency stop, or e-stop, in a control cabinet is 42 inches, which is equivalent to 1070 mm above the floor. This height restriction is in place to ensure the e-stop is easily accessible during an emergency situation. Placing the e-stop within this specified height range allows personnel of varying heights to reach and activate the button quickly and efficiently. Accessibility is crucial for effective emergency response. If the e-stop is placed too high, it may be difficult for shorter individuals to reach, delaying the shutdown of equipment and potentially exacerbating the emergency. Conversely, placing it too low might make it less visible or accessible, especially in cluttered environments. The 42-inch limit represents a compromise, optimizing accessibility for a wide range of users while maintaining visibility. Several standards and regulations address the placement and requirements for emergency stop devices. Although the specific standards might vary depending on the jurisdiction and the type of equipment, they generally emphasize the importance of accessibility, visibility, and ease of use. For example, the American National Standards Institute, or ANSI, and the National Electrical Manufacturers Association, or NEMA, provide guidelines and standards related to industrial control systems, including the placement of emergency stop devices. These standards aim to promote safety and prevent accidents by ensuring that e-stops are consistently located and easily identifiable. Compliance with these standards is essential for manufacturers and operators of industrial equipment. Failure to adhere to these regulations can result in fines, legal liabilities, and, more importantly, increased risk of accidents and injuries. Therefore, it is crucial to understand and follow the relevant standards when installing or maintaining control cabinets with emergency stop buttons. Regular inspections and maintenance should be conducted to verify that e-stops are functioning correctly and are easily accessible. This includes checking the height of the e-stop, ensuring that it is not obstructed by any objects, and verifying that the button is clearly labeled and easily identifiable. Training personnel on the location and proper use of e-stops is also essential. Employees should be familiar with the procedures for shutting down equipment in an emergency and should be able to quickly locate and activate the e-stop buttons. This training should be repeated periodically to reinforce the importance of emergency preparedness. In addition to the height requirement, other factors should be considered when placing e-stops in control cabinets. The e-stop should be located in a position where it can be easily seen and reached from various angles. It should also be protected from accidental activation, such as by a protective shroud or guard. The color and shape of the e-stop button are also important considerations. E-stops are typically red and have a mushroom-shaped button to make them easily identifiable. This standardized design helps to ensure that anyone can quickly recognize and activate the e-stop in an emergency, regardless of their familiarity with the specific equipment. The background color around the e-stop should also be chosen to provide contrast and enhance visibility. A yellow background is often used to make the e-stop stand out. The labeling of the e-stop is also crucial. The button should be clearly labeled with the words "emergency stop" or a similar phrase. The label should be durable and easily readable, even in low light conditions. The labeling should also comply with relevant standards and regulations. The placement of e-stop should be carefully considered during the design and installation of control cabinets. A risk assessment should be conducted to identify potential hazards and determine the optimal locations for e-stops. The risk assessment should take into account factors such as the type of equipment being controlled, the potential for accidents, and the number of people who may be exposed to the hazards. The results of the risk assessment should be used to inform the placement of e-stops and other safety devices. The integration of e-stops into the overall safety system is also important. E-stop should be connected to a reliable control system that can quickly and safely shut down the equipment in an emergency. The control system should be designed to prevent the equipment from restarting automatically after an e-stop has been activated. This helps to prevent further accidents and injuries. The control system should also be regularly tested to ensure that it is functioning correctly. The testing should include simulating emergency conditions and verifying that the e-stops are able to effectively shut down the equipment. The results of the testing should be documented, and any necessary repairs or adjustments should be made promptly. In addition to the e-stop button itself, the control cabinet should also be designed to provide a safe and ergonomic working environment. The cabinet should be properly ventilated to prevent the buildup of heat or fumes. The cabinet should also be designed to minimize the risk of electrical shock or other hazards. The cabinet should be constructed of durable materials that can withstand the rigors of the industrial environment. The cabinet should also be properly grounded to prevent the buildup of static electricity. The maintenance of control cabinets and e-stops is an ongoing process. Regular inspections should be conducted to identify any potential problems. Any damaged or worn component should be replaced promptly. The cabinet should also be cleaned regularly to remove dust and debris. The maintenance program should be documented and should include procedures for inspecting, testing, and repairing e-stops and other safety devices. The documentation should also include records of any accidents or incidents that have occurred. This information can be used to identify trends and to improve the safety program. The safety program should also include provisions for training and education. Employees should be trained on the proper use of control cabinets and e-stops. They should also be educated about the potential hazards associated with the equipment being controlled. The training program should be updated regularly to reflect changes in technology or regulations. The use of e-stops is an essential part of a comprehensive safety program. By following the guidelines and standards outlined above, employers can help to ensure that their employees are protected from accidents and injuries. The 42-inch height requirement is a critical element of this program. Ensuring that e-stops are easily accessible is a simple but effective way to improve safety in the workplace. It is important to consult the specific standards and regulations that apply to the equipment being controlled. These standards may vary depending on the jurisdiction and the type of equipment. However, the general principles of accessibility, visibility, and ease of use should always be followed. The 42-inch height limit for e-stops and control cabinets is a well-established safety requirement. By adhering to this requirement, employers can create a safer working environment for their employees. Regular inspections, maintenance, and training are also essential to ensure that e-stops are functioning correctly and are readily available in an emergency.